Hello everybody. Today we finally get to the beginnings of proofs. You're going to do basically your first proof today. I'm going to show you in the video, but we're going to use something that we already know how to do. Now, the name of this chapter is Reason Using Properties from Algebra. So basically what we're going to do is we're going to prove equations, algebraic equations. We're going to put them in the form of a proof. Okay? So the first thing we're going to need to talk about, algebraic properties of equality, distributive property, reflexive, symmetric, transitive properties. All these properties, what they mean and how we use them. Okay, so let's go ahead and get started. Algebraic properties of equality, addition property. Okay, real simple. If A equals B, that means I can add, oops, this should be a C. Gosh dang it, that should be a C. If A plus C equals B plus C, I can add the same thing to both sides, and this should be a C also. Okay, so subtraction. A minus C equals B minus C. I can subtract the same thing from both sides. Multiplication. I can multiply the same thing to both sides. Division. I can divide by the same thing as long as that thing is not 0, because you're not allowed to divide by 0. Okay, dividing by 0 is undefined. And if A equals B, then you can substitute B in for any A, okay, in the expression. Things we've all done before, okay, things we all know how to do. And this, gosh dang, I didn't copy this down right. This should be substitution. Okay, substitution. Okay, here's the meat of this. I'm not worried about you guys knowing this. You should already know this by now. Okay, you passed Algebra 1, you should know this by now. What I'm more concerned about is the proof part. Okay, and we're going to use equations here to do a proof. Now I know you know how to solve that. Okay, don't think I'm insulting your intelligence by making you show all these steps with this. What we're doing is we're going to use this algebra to do a proof because we know how to do the algebra. It's easy. This is something that we all know how to do. It's easy. We're just going to put it in another format so we can get used to the proof format. Okay? So here's what's going to happen. Everything we do is going to be a statement. But we need to have a reason for everything we do. So we call this a T-proof. We need to have a T-chart. Okay? And obviously here's the T right here. Okay? So the first thing we do is write down our first statement, which is 2x plus 5 equals 20 minus 3x. And what's the reason for that? Well, it's given. Your first step is always given. It gave you the equation right here. Okay? First step is always given. Now, we're going to go through and use these properties from up here. Okay? What's the first thing you do to solve this? Well, first thing I do is subtract 5 from both sides. So we have to write that down. 2x plus 5 minus 5 equals 20 minus 5 minus 3x. Notice I'm subtracting 5 from both sides. Well, what property was that? That was the subtraction property. So that's our reason. That's the reason we can do that. Subtraction property. Okay? Now I can actually subtract, which I'm going to get 2x plus 0, so I don't need to write it, equals 20 minus 5 is 15 minus 3x. Okay? And that was just actually subtracting. Isn't that what I did? I subtracted negative 5 from 5 and negative 5 from 20. So that's my reason. Okay, I used the property to add more numbers to it, but then I just subtracted those numbers. Okay. Now the next thing I would do to this is I would add 3x to both sides. So 2x plus 3x equals 15 minus 3x plus 3x. Okay, and that would be the addition property. Okay, that's my reason for doing it. I'm adding the same thing to both sides. And now I can just go ahead and add things up. Well, this is going to be 5x equals 15 because that's going to end up being 0. That's just straight addition. That's all I did is I added those numbers up. Okay? Now the next step I'd have to do is divide by 5 because I got to get x by itself. So I need to divide by 5. So 5x divided by 5 equals 15 divided by 5. And why can I do that? Well, that's the division property. Okay? Because 5 is not 0. As long as whatever I'm dividing by is not 0, I can divide the same thing on both sides. Okay? Now I actually divide, and I end up with 1x equals 3. And that's just straight division. And I'm done. Once I have my answer, once I have what I'm looking for, I'm done. And in a proof, when you're done, it's just like a period, okay? We draw a little box and we color it in. That signifies that I am done with the proof. I have proved whatever I have set out to prove. Okay? So notice, you always start out with the given. It tells you what the given is. And then you have to use these properties to explain and define what you're doing. Now, I know that's a lot of steps for an algebra problem. Again, the point of this is not to do the algebra. The point of this is to get used to this T-column concept so that you can use proofs. I know you know how to solve that in faster methods. The point of it is not to solve the algebra. The point of it is to get used to showing a reason for every single step you do, because that's what you're going to have to do with a proof. You need to think about giving a proof. Whoever's reading your proof has no idea what you're talking about. Okay? You know it better than they do, so you have to show them every single step so they don't get lost. Otherwise, they're not going to believe your proof. Okay? Let's take a look at another one. Distributive property. Okay? We all know the distributive property. We've been there. Okay? We multiply the a by everything inside, so we end up with ab plus ac. Okay? Well, let's practice using the distributive property with doing a proof. Okay? So let's do another one. We'll do this one in red this time. Okay? First thing we do, negative 4 times 11x plus 2 equals 80. And that's given. My reason for that is it's given. It gave it to me in the problem. Okay? You should not get the given wrong. No one should ever leave a proof blank because you can at least do the given. Okay? Here we go. Now, first thing I want to do is distribute, obviously. So this is going to be negative 4 times 11x plus negative 4 times 2 equals 80. And the reason for that is distributive property. Okay? Because I can multiply that negative 4 by everything inside there. Well, now I'm going to actually multiply. So that gives me negative 44x plus negative 8 equals 80. Okay? That was just multiplication. What did I do? I multiplied. Okay? What's the next step you do? Well, the next step I do is add 8 to both sides. So negative 44x plus negative 8 plus 8 equals 80 plus 8. Okay, that's the addition property from before. I'm adding 8 to both sides. I can do that as long as I do it to both sides. Now I'm just going to go ahead and add. So I have negative 44x plus 0, so I'm not going to worry about it, equals 88. And that's just addition. Okay, we're almost home here. We're almost home. Last thing I need to do is divide by negative 44. Negative 44x divided by negative 44 equals 88 divided by negative 44. Okay? This is the division property. Right? I'm dividing by the same thing on both sides. So now if I actually divide, I get 1x equals negative 2. That's just division. I have now solved the problem. I am done. So I box it. Okay? I box it. Good stuff. Good stuff there. Okay, division property. And again, I can't reiterate this enough because somebody's going to come up to me and say, why are we doing all these steps? Why are we doing all these steps? And I'm going to say, you know what? It's not the algebra. It's not the algebra we're concerned with. I know you know how to do algebra. What we're concerned with, it's using something we know, like solving an algebra problem, and listing every step, a reason for every step, because that's what we're going to have to do in proofs. You're going to have a reason for everything you do. Okay? Just like we have a reason for everything we do in algebra, we don't necessarily state it all the time, but you're going to have to state it when we do proofs in geometry. Okay? All right, let's finish this thing up. Reflexive property. Now, we'll get into where these come into play when we get to class, but basically it means that anything equals itself. A equals A, AB equals AB, angle A equals angle A. And where you'll use this, like let's say we have, two triangles like this. Well, if you're going to prove these things are the same, I mean, you can see that, like if this is AB, we'll just do this. this AB goes with this triangle and with this triangle, but I have to state it twice because it goes with the first triangle on this one and the second triangle there, even though it's the same line. I still have to tell you it equals itself. Okay? Just a goofy math thing we have to deal with. Reflexive property, anything equals itself. Symmetric property, you can flip-flop things. Okay? If A equals B, then B equals A. If AB equals CD, then CD equals AB. You can flip things on the other side of the equation. Okay? And that's one of the steps we use at the end to make sure things are exactly the way we like them. And then the transitive property. Use this one a lot. It's very similar to the law of syllogism, that law of logic. If A equals B and B equals C, then A equals C. We can say that. So if A equals 6, okay, and 6 equals C, then we can say that A equals C. We know that. Okay, we can get there. Okay, I probably shouldn't use 6 because it looks too much like a B. But transitive property, a lot like the law of syllogism. Remember the law of syllogism? If A happens, then B happens. If B happens, then C happens. So therefore, we can say if A happens, C will happen. Okay? Transitive property. And we'll clean these up a little bit more in class. It's kind of hard to demonstrate where you'd use them on the board here in a video. Okay? So, reason using properties from algebra. Went through all the properties, and I messed a lot of those up, didn't type it correctly. Okay? Properties of equality, distributive property, reflexive, anything equals itself, symmetric, you can flip things over the equal sign. Transitive, if A equals B and B equals C, then A equals C. Okay? Hopefully this makes some sense, and we'll practice some more of these in class, but we are finally to proofs, finally to seeing how proofs work. All right? We'll see you in class.